Hey there. This is going to be your practice exam number 5, which is quiz number 5. And we're going to go ahead and start. And I'm going to share my screen here. And we're going to start with problem number 1, which is we're going to find all the variables of x, which makes the rational expression undefined. And what that means for us is we're going to have an expression like this. And it is undefined when 2x plus 2 equals 0, meaning we can't divide by 0. So if it becomes 9 divided by 0, we have a problem. And I can even show you what that means. 9 divided by 0, we run into a problem. It says, hey, you can't do that. Stop doing that. So we want to know what value of x is going to make that happen. So to do that, I just need to solve this small equation. So x in this case cannot be -1. This is the value of x that makes the expression undefined. And that's quite a statement in a math thing, meaning we don't even have a definition for when x equals -1 here. We got a problem. Notice -1 times 2 is -2 plus 2 is 0. That's no good. Next up, we are going to simplify. This is number 1. I should number these. Number 2. 9x squared plus 15x plus 4. 9x squared minus 16. And we are to simplify this, meaning we're going to try to reduce this, which means I need to factor both the numerator and denominator. Now the denominator is the difference of squares. That one's easy. 3x minus 4, 3x plus 4. However, the numerator, not so much. So I'm going to go to my paper here. I'm not going to do this for all of these quadratics, just for the first one. The way I taught it, it's 9 times 4 goes up top, 36. 15 is down below. And now I need a combination that when I add up, I get 15. That's going to be 12 and 3. So 9x squared plus 12x plus 3x plus 4. There's nothing to factor there, so I'm just going to put a 1. So here I have 3x plus 4 and 3x plus 1. And I'm going to notice that the 3x plus 4s reduce out. I'm left with this here. Now, it might look like the 3x's can reduce, but they can't. That's definitely something you can't do because I'm adding and subtracting in there specifically. If this was 3x times 1 or 3x times -4, then I could reduce. But because I'm adding and subtracting, that's not going to work out, unfortunately. Number 3, we have a multiply. So I have now again, in your practice exam or quiz number 5, you are going to have different numbers than I do, different expressions, but the process is going to still be the same. And when we multiply, everything just gets multiplied across. However, I'm going to factor that. That's a difference of squares again. So there's my x squared minus 9 there, times the x plus 9. Here, this is going to factor into x plus 9, x minus 3, times 2x. And I'm going to note that the x minus 3's reduce, and that the x plus 9's reduce. So after we multiply, of course, we need to try to simplify it. There we are. Next up, we have division. And I need to check. We're good. Number 4. Here we're doing division. And although I will eventually have to factor all 4 of these pieces, the big thing to remember with division is when I'm dividing, I'm actually multiplying by the reciprocal of the second fraction here. And so what's going to happen now is I'm going to factor this times factor that, divided by this factored times this factored. So I'm going to factor all of it all in one step. If you need to go through each process for each of them, then go ahead and work all that out. That's totally fine. So up top, I'm going to have x minus 3, x minus 1. That's that factored. Times this factored, this is the difference of squares. Over, and then now I'm going to factor that. And I'm going to factor this here. And now we got a lot to reduce. Let's start with the x minus 3's. X minus 1. And x minus 5. I'm left with that as my final answer. Number 5, I'm going to try to squeeze in down here. Here we're going to add this here. And when we add or subtract fractions, we need a common denominator. And in this case, x minus 7, x minus 1, they have nothing in common. So the LCD, the least common denominator, is x minus 7 times x minus 1. So what's missing over here is the x minus 7. What's missing over here is the x minus 1. And that gives me all of this. Now be careful, some students, they want to start slashing stuff out. You can't do that yet. We have to actually FOIL these two together and then combine like terms. Ooh, let's see if I can fit that. So that's minus 21. That's kind of hard to see. I'm going to keep going anyway. So now we're down here. Up top, I'm going to combine it by like terms. 2x squared. 9x minus 4x is plus 5x. And negative 10 minus 21 is 31. And down below, I have this here. And I would try to factor that top part, but 31 is a really awkward number. It's prime number, and it doesn't, 2 times that is not going to give me anything that's going to add up or subtract a 5. All right, so let's move on to number 6. Number 6, we're going to subtract. And you'll notice we have the same denominator already. Yay. That makes it a lot easier. I don't have to find a common denominator. I will factor it. However, the big trap here is I got to remember when I'm subtracting, I have to distribute the negative 1. So it's going to look like this. Notice how I distributed the negative to make that a negative 49, and then negative times a negative 10x gives me a positive 10x. All over it. And I'm going to go ahead and factor this common denominator here. Which is nice. Up top, I'm going to go ahead and combine up my like terms. And I'm going to notice that the negative 10x and the 10x cancel out completely. Now I need to try to simplify my final fraction here. And I'm going to notice that up top I have a difference of squares. This becomes x minus 7, x plus 7. And I'm going to notice that I can reduce the x minus 7s. Once again, you might be tempted to reduce those x's. That doesn't work that way because I'm adding and subtracting in between. So this is my actual final answer. All right. We are to solving an equation. Actually, yes, we are. So 6 over x equals negative 8 over 3x minus 8. Now with an equation, I need to find the LCD between the fractions, and that x and 3x, that's going to be 3x. So I'm going to actually multiply all the way through by 3x. And to save space, I'm going to actually go this way. You'll notice I'm distributing this to everybody. Everybody gets the 3x. And here the x is reduced, and I'm left with 3 times 6, which is 18. Oh. Equals, here the 3x is completely reduced. And here I get minus 24x, because 3 times 8 is 24. And now I have a nice simple linear equation to solve. x is going to be negative. Now I can reduce a 2 out of both of those. That's going to be 13 over 12. And we are to number 8, which is a complex fraction. And what I need in this case is a common denominator between all the little fractions. So here m is a denominator, here m squared is a denominator, and I'm going to multiply everybody by that common denominator, which in this case is going to be m squared. And what that's going to do is that's going to reduce all those fractions so that I don't have to deal with them. I still have to simplify though. This gives me m squared plus, now here, the m squared over the m reduces to just be a 3m. There's just one m after I reduce those out. Here the m squareds completely reduce out. So I'm here. Up top, I'm going to factor out a common factor of m. Down below, I'm going to notice it's a difference of squares. I'm going to notice the m plus 3's reduce out. All right, I'm doing on space here. Let's switch that up. I'm going to squeeze 9 here. Then we have another equation. This one's much more robust. And I'm going to note, that's x plus 9 down there, that this actually factors into these two here, which textbook problems tend to do that. So that is what I'm going to multiply by. And when I multiply that here, the x minus 2's disappear, and I'm left with x times x plus 9. Here, the x plus 9's reduce, and I'm left with negative 7 times x minus 2. And here, the denominators completely cancel. They're gone. So here I'm going to distribute combine. And be careful, I'm distributing a negative 7 there. That means I'm going to have to change both signs. I'm going to combine them by like terms. Oops, negative 2x plus 26. And because I have a quadratic, what I'm going to do is I'm going to get the whole thing equal to 0. By adding a 2x and subtracting a 26. Giving me a quadratic. So I'm going to come up here. I'm going to factor that. And then set each piece equal to 0. And I got to be careful. X can't be 2, and x can't be -9. Both of those are going to cause problems. So I have two potential solutions. However, x equals 2 is going to cause a problem right there. It'll cause a problem there too, but we can see right away 2 minus 2 is 0. That one's out. So my only solution in this case is -6. So we only have one solution in this case. X equals -6. All right, so let me readjust my page here. There we are. Number 10. And for number 10, I'm going to share my other screen because it's a word problem. So here's number 10. One inlet pipe can fill an empty pool in 8 hours and a drain can empty a pool in 16 hours. How long will it take the pipe to fill the pool if the drain is left open? So the drain is subtracting from it. So I'm going to let you read through it again. You can pause the video if you need to. I'm going to go back to the other screen. And I'm going to let x equal the time to drain. And this is, both are open. Meaning the inlet is putting water in and the outlet is letting it out. I'm not drain, fill, pardon me. So the inlet pipe can fill it in 8 hours. So that's one pool in 8 hours. And we can drain the pool, the same pool, in 16 hours. And so it's going to fill the one pool in X hours. That translates to 1/8 minus 1/16 equals 1/x. So there's our equation. The LCD in this case is 16x. (16x over 8x is 2x. 16x over 16 is x. And 16x over x is just 16. This means that x equals 16 hours. So if the pool drains in 8 hours, fills up in 8 hours and drains in 16 hours, if they're both left on, it's going to take another 16 hours to fill the pool. I'm going to go back to the original question so you can review it again. Again, it's subtract because the drain is letting water out. If it was another inlet pipe, if that was older and wasn't as efficient, then you would add them together. Next up, we have question 11. We have a woman can ride a bicycle 44 miles in the same time as it takes her to walk 16 miles. She can ride 7 miles an hour faster than she can walk. How fast can she walk? Let me give you a minute to read through that again. And let me switch over. You can always pause the video if you need to read it longer. And I'm going to let x equal the rate she can walk. This means that x plus 7 is the rate she can bike. And we're going to use rate times time equals distance. However, I'm going to modify this a little bit and divide both sides by r. And that's going to be our primary formula that we're going to be using here. I'm going to use a table to help me organize my stuff. The rate she can walk is x. The rate she can bike is x plus 7. She's faster on a bike. Makes sense. The distance she can walk is 16 miles. The distance she can bike is 44 miles. The key phrase here, let me switch back real quick, is here. Same time. Same for us means equals. That's our equation. That's getting us everything that we need. Now I'm going to use my formula here. My time is going to be my distance, in this case 16, over my rate, which is x. Again, my time is going to be my distance, 44, over x plus 7. And what we just saw in the word problem is that our times are the same. I'm going to cross multiply here. There's my equation. Let's speed that up a little bit. And I'm going to distribute the 16. And I don't know 16 times 7 off the top of my head. 112. And what I could have done is gone off to the side here. Seven, 8, 9, 10, 11. And there's my 112 again. Maybe you're not allowed to use a calculator, but you can always fall back on what the kids call old school. All right, and I'm going to go ahead and go 44 minus 16. It's 28. I could have moved the 44x this way. It's the same. You'll get the same answer. And just to be clear. That is 4 plus 4 is 8. 8. I'm going to divide by 28. And x is going to be 4. And that is 4. Double check my units here. Miles per hour. And just to verify that, if I do 28 times 4, 2, 3, 8, 9, 10, 11, you can see I'm going to get 4 from that. And that's it. That's the whole practice test. Certainly watch through this video as often as you need to. Thank you.